All right, so basically, right now there's an issue going on, and what we're gonna have to do with that is take the logical next step, which is the name of the solution. It's the logical solution to this issue here about essentially computer hardware and software are obviously two different things when it comes to the world of the digital world, which is like most of today. What's currently happening is software development is being very heavily focused on, like, we're teaching young kids how to code and all that. I know at least four of us are in comp sci here. Everyone's learning how to code and how to code things better, but that is also going to mean that we're going to need more. We're going to need better machines to run the more advanced code that ends up coming out of this whole process of everyone learning how to code, because the quicker we start advancing there without advancing in hardware, the slower everything's gonna happen. It's gonna bottleneck. If you ever build a PC, that's gonna happen. You get a good graphics card, not a good processor. So that's essentially what's happening. We have good code, but no good software, but not really any good hardware. So like stuff like Hour of Code, basically. We're teaching kids how to code, but not really how to make things that run code. So in research, my old partner for what this project originally was, Andrew, he went down to the Texas Instruments manufacturing facility, and he saw a lot of the stuff that they build. But they've been essentially the only reason that Texas Instruments itself is still in business today is because of the calculators that they sell to the schools. They're now, although they are one of the biggest computer hardware manufacturers out there, and they design and a lot of the stuff that goes into computer hardware now, it's not as much as it should, and so a lot of businesses like Texas Instruments are already going out of business. So, first of all, we just kind of went around with the small children that we come into contact with, cousins, siblings, whatever, and they're just not really educated or care to be educated about the hardware that is running everything, kind of what's behind it. So we went in with Texas Instruments and a couple others to see, and ask them about employment with engineers for hardware, and they're few and far between is kind of what we figured out there. And so we kind of went through a few solutions, like a curriculum in the school, like adding curriculum to schools, which would be kind of difficult to do. Maybe trying to add more physical technology into the classroom that is kind of centered around that, or just kind of combine them for that third one there. The thought process. Come on. There. And so we did a bit of CAD on this. It didn't really need to be much. That was made on Google Chrome. And don't let this intimidate you. It's really quite simple. It's just that for each of these logic gates, there's a truth table, meaning out of the two inputs, a certain output will happen. 1 is on, 0 is off. For the AND gate, both have to be on for it to be on. For the NAND gate, both have to be off. For the XOR gate, it's supposed to just be X. One can be on, but not both. For it to turn on, it's difficult at first, and the NOT gate just reverses all of them. The OR gate, either of them can be. And so what we kind of did there is we made this into this, which is essentially a switch, and where would have been a button on each and every single one of these, or for each and every single one of the 7 basic logic gates, for a little kid to flick the switches, push the buttons, and kind of see see what happens, and figure some cool stuff out on that. It's very basic and is meant for small children, so that they can just kind of get used to the idea of this kind of stuff. If you're in comp sci, it's Booleans. It's the Boolean things. And so, essentially, we wanted to implement this into some form of curriculum. Maybe just give it to some little kids and let them play with it for a while to get them interested in the physical technology behind behind or in front of, depending on where you're looking at it, the software. And then once they're kind of used to this kind of to the concept itself, you kind of give them what it works with as a whole, and then out of that will come young adults who are more interested, and hopefully more curriculum and stuff will be added to continue that interest, so that we have both software and hardware engineers going at it, making making really nice computers that can run really nice software in the future. So at the end of this, or the end of this whole thing, because I forgot to link a lot of my stuff, or namely the connections. If we were to implement something like this, it would allow us to make cheaper, really good technology, like the 2080 Ti, how it's really, really, really expensive and no one wants to buy it except for rich kids. That kind of stuff would be cheaper, and it would, because we'd be able to get more of it done, and it wouldn't take as long. Not to mention, that would also allow software to kind of boost forward, and as Thanos would say, to keep it all in perfect balance. Yeah, that's all. Forgot to link my connections because I worked on this late at night.
So, do the switches link to a light?
They would have been linked to a light that would have just recognized output, but family things happened and I couldn't even get my parents to sign my form for the thing, so I didn't get to head over to my grandparents and solder these on.
Okay, but it would
work. It is
connected to a light.
It is designed, and if you look at the back of this, we've set up the circuits that you just kind of need to stick the logic gates into.
Okay, I'll see how that works. Okay, thank you very much.